How do I set up a local certificate authority to encrypt traffic for internal websites over HTTPS? I think we should find out. Securing public websites is done by buying certificates from trusted certificate authorities like Symantec, DigiCert, and GeoTrust. Certificates cost money, but they do give us peace of mind that data on websites is trusted, encrypted, and safe. That's all well and good, but what if we want to run websites on our internal network? Maybe for testing and development, or even a home lab. In this case, we can set up a local certificate authority and tell our network devices to trust it. With this trust in place, we can issue certificates to our local servers signed by our local certificate authority. In this example, I have two servers set up. One is running an Apache web server, and the other is running Hyper-V with Windows Admin Center. In fact, it's the Hyper-V server set up in episode 4. You can check it out in the IT Skills Library playlist. From a Windows PC, Edge and Chrome both report that both sites are insecure on both servers. From an Ubuntu PC, Firefox also tells us that we can't trust the two servers. So it's this trust that we want to establish to secure both sites so that the traffic going back and forth is encrypted using HTTPS. The plan is to set up a local certificate authority which has its own private and public keys for encryption. The public key is in the form of a certificate that is copied to our clients, which means they can now trust our local CA. Now the two servers need to create a trust relationship with our local CA in the form of a signed certificate. To get this certificate, a private key is generated and is used to create a certificate signing request. This CSR file is sent to the CA to sign the request with its private key and generate the signed certificate and send it back to the server requesting it. Armed with this certificate, when our clients connect to the two servers, they will trust them, and any traffic is encrypted using HTTPS, which is a combination of HTTP and TLS. So the first step is to set up the certificate authority. Next is to copy and install the public certificates to the two client PCs. The next step is to create a certificate signing request. Next is to generate a signed certificate for the servers. And the last step is to test if the clients trust our servers. All these certificates may seem complicated at first. The key concept here is that when the clients and servers talk to each other, they trust each other because of their mutual friend, the local CA. When setting up your environment, you will need a local DNS server or the server names listed in the host files of your systems. This is important because the server name on the certificate has to match the name on the URL typed in the browser. Let's start with the certificate authority first. I have a fresh install of Ubuntu server and install a package called EasyRSA, which allows us to create a certificate authority in a few easy steps. This directory will be linked to the files installed in the default location for EasyRSA, and I can do this with the ln command. Now all the files here are linked to the CA01 directory. To keep this directory secure, I'll change permissions to allow only the owner access to the CA01 directory. Now we're ready to set up the public key infrastructure or PKI of the CA by running the EasyRSA script with the init PKI argument. The PKI is the structure the CA uses to store, create and issue certificates. An example config file is stored in this directory, and I'll make a copy of it, naming it vars. This file will contain info about the CA and I'll customize the settings to suit my needs. The hashtags are used to comment out the lines, so I'll remove those as well. The information here will be displayed in the certificate installed on client devices And since this is internal, only devices inside my lab or organization will see these values. For public certificates, this information is more important. Okay, so I'll write and quit to save the file. Now I'm ready to build my certificate authority with the build CA argument. This passphrase is to keep the keys for this CA secure and will be needed when signing certificate requests, so don't forget it. The common name can be set to anything here, as this is the root CA. Other certificates need to match the common name of the server being trusted. This public key certificate will be copied to any clients that need to trust this certificate authority, and the private key that is super secret and should be protected at all costs. Back on the Windows 10 PC, I'm going to get a copy of the public certificate from the CA server using PowerShell and the secure remote copy command SCP. The certificate is in the PKI directory, and I'll copy it to the Documents folder on this PC. We can see the certificate is issued using the common name that we set earlier and is valid for 10 years. When installing the certificate, we install it for the local machine and put it in the trusted root store. On the Ubuntu PC, I'll copy the file using SCP again, and instead of installing the certificate system-wide, I'll install it in Firefox directly. In Certificate Manager, I pick the Authority tab and choose the option to trust the CA that this certificate belongs to for websites. A quick check shows the certificate is installed. This means that both the Windows and Ubuntu client trust the CA we set up. The next step is to create trust between the servers and the CA. Back on the CA server, I'll create certificate signing requests for both the Web01 and Hyper-V01 servers. Normally this is done on the servers themselves and sent to the certificate authority, but since this is a local CA, I'll create a temporary folder for these requests and create them here. I'm in the CA01 directory and I'm going to create the temporary folder. OpenSSL is a collection of tools used for security over networks, and this is what we'll be using. The first thing to do is to create the private key for Web01. So I'm going to do gen RSA out, and this is where I want to create the private key. So it will go into the temporary folder, and I'll call it Web01. Now I'll create the certificate signing request. So it's request and it's going to be new. And I'll need to use the key that we just created. And the request file will be saved in the same location. And again, I'll call it web01.req. Here I'll fill in some defaults for the certificate. The common name is the most important value here. It has to match the URL of the web server that we're creating this certificate for. If it doesn't, the certificate won't work. I'm going to leave the password blank here since it's a local CA. So now we've got both our private key that we needed for the request, and we have the request file that's going to be signed by this local CA. Now let's create a request for Hyper-V01. So first is the private key. Gen RSA. And we'll call this Hyper-V01.key. and we'll use this key for the request. So it's a new request, and the key file is this one. So we'll save it in the temp directory again and call it hyper-v01.req. Same thing here, we need to fill in some basic details. Again, I need to make sure that this matches the URL of the web server that this certificate is for. So we have our two request files, and the next thing to do is sign them. Signing certificate requests from servers is like a seal of approval that lets any client know that this CA has approved the server as trustworthy. The request is signed with the CA's own private key, so that's why it's so important that this private key is kept super secret. If someone gets hold of this key, they could then use it to sign their malicious servers as trustworthy and cause all kinds of damage to clients. Let's sign the request for Web01 first. I'll use the EasyRSA script file to import the request file first. I'll call the certificate Web01. Now I'll go ahead and sign the request. And we put server down here because we're signing a server request. So I get a summary from my vars config file that this is how it's going to be signed. I confirm yes for the details. And now I'm being asked for the passphrase that we set on the private key for this CA. So I'm just going to enter that in. And I can see I've been issued a certificate, which is in the issued directory. This is the certificate I now need to install on my web server. I'll now do the same for the Hyper-V server. Now I'll sign the request, and again I'm signing a server request, the super secret password. Next we need to install these certificates on both web servers, so let's start with the Apache web server first. To configure Apache to use HTTPS instead of HTTP, we need to copy the private key and the issued certificate for Web01 from the CA server. We then need to configure Apache to use HTTPS, enable SSL, and restart the Apache web service. Let's create the directory for the certificates first. I'm going to call the directory certs. Now I'll use SCP to copy the private key and the certificate. So we have our private key and our certificate. Next, I'll make changes to the Apache configuration file. So the first thing to do is change this to port 443 for HTTPS. Next, I'm going to turn on the SSL engine. Then I'll let Apache know where the certificate file is. And lastly, I'll let Apache know where the private key is. Next, I'm going to enable SSL. And now I'll restart the web service. And now you can see the web server is working, and if I look here, you can see the connection is secure. And the certificate itself, we can see it's issued to this web server, and it's issued by the local CA server that we've set up. Let's also check Google Chrome. And again, we have the padlock sign, and it tells us that the connection is secure. Let's also check Ubuntu. So the connection is secure in Firefox as well. And you can see it's verified by our local CA server. The last thing left to do is install the certificate on the Hyper-V server, and before we do that, we have to go back to the CA server and convert the certificate to a PFX file. Windows servers prefer this format because it includes both the private key and issued certificate in the same file for the requesting server. On the CA server, I'll use OpenSSL and PKCS12 to do the conversion. The in key will be the private key for the server, and in will be the certificate. I'll export it out to the PFX format and put it in the issued folder. Now I have the PFX certificate file, I can go over to the Hyper-V server. On the server, I'll use SCP again to get the PFX file. To import the certificate on this server, I'll need to provide the password for the private key, so I'll save that in a variable. Now I'm ready to import the certificate. I'll put it in the default location for certificates, which is local machine my, and specify the password. The certificate is now imported on the server, and all that's left to do is configure it for Windows Admin Center, and for that we'll need the thumbprint which is displayed on screen. I have the Windows Admin Center install file on this server, and I'll run it again to install the new certificate. So this is the thumbprint of the self-signed certificate that Windows Admin Center normally installs. In here I'm going to put the thumbprint of the certificate we just imported. Right, now we're ready to check whether the browser recognizes the certificate. So now we can see we've got the padlock sign and the connection is secure. We'll check in Chrome as well. And again, the connection is secure. The last step is to check in Ubuntu and make sure that Firefox also recognizes the new certificate. And again, Firefox is happy with the certificate that the certificate authority has issued. So, this is how you use a local certificate authority to set up trust between internal servers, whether that's in a lab or in your organization. This makes sure your internal servers are secure and that connections are encrypted. That's it for this episode. If you're new here at STech Systems, the IT Skills Library is a collection of questions and answers to build your IT skills one answer at a time. Subscribe now and start building your skills today.